Hello, everyone. This is Kyle Welch from RCR Wireless News. I want to thank everyone for attending 2015 Outlook for Indoor Wireless Technologies, presented by Corning and ABI Research. Our presenters today are Jason Green from Corning Optical Communications and Nick Marshall from ABI Research. Jason Green, Director Solution Architecture at Corning Optical Communication, has 14 years experience in the fiber optics industry, specializing in wireless and wireline network design. During his career, Mr. Green has held a variety of positions at Nortel Networks and Corning, including product development, product management, and various commercial roles. In his current position at Corning, he serves as solution architect for Corning's wireless initiative, including active DAS, fiber to the antenna, and fiber backhaul for wireless networks. Mr. Green holds a bachelor's degree in engineering from Auburn University and an MBA from Georgia State University. He holds several patents and has authored numerous articles, white papers, and application notes on fiber optic solutions and their applications, and is a frequent speaker at industry events. Nick Marshall, Research Director at ABI Research, is responsible for publishing industry research on wireless radio access networks, including macro base stations, small cells, and carrier Wi Fi, enterprise and consumer femtocells, in building wireless, and mobile backhaul. Nick has more than 25 years of experience in the wireless industry at Freescale and Motorola, where he held various positions in product management, engineering, and marketing in the UK, France, and the US. Prior to joining ABI Research, Nick worked as a market intelligence analyst specializing in wireless devices and networks for Freescale Semiconductor in Austin, Texas. Nick earned a Bachelor's of Science in Physics from the University of Glasgow and is a graduate of the Institute of Physics from the University of Paisley in the UK. At this time, I'd like to turn the webinar over to Jason.
Thanks, Kyle. Hello, and thank you to everyone for joining us today. Before we go into the agenda, I'd like to take a moment to frame our conversation. It's not surprising to point out that in today's ecosystem, where DAS has been used for over a decade for providing both coverage and capacity growth, small cells are starting to grow, and it is expected that they will catch up to DAS. The most recent analyst reports agree that the technologies, however, are more synergistic rather than competitive, and that infrastructure convergence makes the most sense when it comes to deploying mixed environments with DAS, small cells, and Wi-Fi networks. During our time today, we will be sharing with you the trends and forecasts in building wireless. ABI Research believes that DAS and small cells will serve discrete market segments for the most part. DAS likely to be deployed in large and medium-sized venues, primarily more than 150,000 square feet, and small cells will be used to deploy in smaller buildings. What I think is more interesting is that the report also points to the fact that small cells' biggest impact on DAS is actually in a support role. ABI estimates that a quarter of distributed antenna systems will eventually be fed by small cells because they are smaller, cheaper, and easier to install compared to macro sites, repeaters, or base stations. I will then close the session with some insights about the challenges ahead and how the benefits from wireless infrastructure convergence for the future of in-building wireless. With that, I'll hand it over to Nick.
Thank you, Jason and Kyle, for that introduction. It's a pleasure to be on a webinar with Corning today. So this should be pretty interesting, I'm sure, and I hope you all enjoy it. Can you all see my slides? I guess, Jason, you can see the topics there. So what I'm going to talk about before handing it over to Jason are the drivers in this market. We're going to talk about exponential growth in mobile subscribers. We're going to talk about the implications of that growth on traffic and in particular on in-building wireless. We're going to kind of have a preview of what an in-building wireless toolbox might contain for modern and future systems. And then I'll pass it over to Jason for deep dive on infrastructure convergence. First, just a few words about ABI for those of you who may not be familiar with us. We've been in business since 1990, and now we have 11 offices in the Americas, Europe, Middle East, and Asia Pacific. We're a technology market intelligence firm operating across 12 research sectors, and we quantify today's important markets and help define the strategic technologies of tomorrow. We also work to provide insight on how technology is adopted in vertical markets. So please check us out if you get a chance. And with that, on to the webinar. So this is our first driver. Subscribers are moving on, and they're driving traffic and network densification. Exponentially growing traffic is the #1 challenge for many operators worldwide. So much so that without densification, macro networks will become overloaded. This situation is accelerated by the movement to 4G, as you can see here when we compare 2013 to 2019. For example, with its higher data rates, it's becoming more popular, and in North America by 2019, we're forecasting that over 85% of subscribers will be 4G. There will be no 2G in North America in 2019, and the number of subscribers on 4G in 2019 will be only 494 million. Contrast that with Asia Pacific. In 2019, the combined 3G and 4G subscriptions will be 3.3 billion subscriptions in 2019, an enormous number. So the key takeaway here is the growth in 4G, and 3G is still growing, and these high data rates on those access technologies have implications for mobile traffic that I hope to demonstrate in the next slide. This is our next driver. Data is driving mobile. Here we're forecasting that 4G traffic will grow 35 times between now or last year in 2019 to several hundreds of exabytes annually. The monthly megabytes per subscriber will also grow, and the highest growth region is North America. That's going to grow 11 times. Not to forget the multiplier effect of these high-speed data access technologies. The faster the data rate, the more subscribers use it, and the more apps take advantage of it, and data traffic growth is accelerated exponentially. So what is all this to do with in-building wireless? In fact, it's widely accepted that 80% of all mobile data traffic originates or terminates indoors. There are some characteristics of traffic that make in-building wireless system design interesting. One of those is what I'm calling tidal. Traffic is a tidal nature. For example, total traffic is lower in an enterprise outside of working hours, 9 a.m. to 5 p.m., say, and high during those working hours. This demands traffic steering and load balancing by the in-building wireless system for efficient use of CAPEX. We've identified 4 major trends we think that are impacting in-building wireless. First and foremost, obviously, 3GPP progression and its continually increasing data rate and complexity is going to make an impact on in-building wireless as it goes to 5G. Virtualization and the whole SDN NFV movement is also proving to have an impact in in-building wireless, and also that's going to give advantages in CAPEX. So we mentioned traffic steering and network convergence. Obviously, networks, in-building wireless networks need to be RAN agnostic and multi-protocol. The next driver is video. The type of data is predominantly video, and you can see that video grows by 18 times by 2019. Handsets are responsible for that, and so I came up with some amazing factoids to illustrate this. Netflix say that they have 50 million members who watch 1 billion hours a month of streaming video. I guess a lot of those would be mobile. YouTube 1 billion users per month watch 6 billion hours of video. 40% of those are mobile. Skype, 1.4 trillion voice and video calls in the last 10 years. Facebook, 1 billion mobile users per month, and so on. Twitter, WhatsApp, and other applications are really illustrate the tsunami of data flooding these mobile networks. So let's move in building. This is another driver, active DAS. We believe drives the in-building wireless market. So again, we're comparing 2013 to 2019. You can see that the hot areas are active DAS and North America. So where we are, where Corning is where the market is. So that's excellent. And that market's followed by Asia Pacific, which outgrows the market, and then Europe in that order. We expect this market to represent $8 billion in equipment by 2019. And we'll move on to system architectures in the next few slides, but we can see that several architectures are becoming available. Distributed antenna systems, DAS, small cells we mentioned, and then distributed radio systems, which are emerging to be an interesting take on in-building architecture. So that with a modern high bandwidth backhaul, fronthaul installed in the building, the groundwork is there for ultimately 5G in 2020 and beyond. We're not exactly sure what 5G is yet, but it's going to be more complex and have faster data rates, which the fiber and fronthaul will handle. Specifically in North America, and specifically in a couple of verticals that we've identified as being pretty attractive, it's the biggest market, North America, and it's only 6% penetrated. And we estimate there's 90 billion square feet of commercial floor space in North America. So there's an excellent potential there and long-term outlook. Worldwide, there are 900 billion square feet available, which is only 2% penetrated. And again, worldwide markets, specifically Asia Pacific, have lots of potential too. And as you see in the chart here, healthcare and hospitality verticals, we are expecting that penetration to grow between 2.5 and 3 times. So these are great areas to concentrate on, and I think we'll hear more about that later. Also, the large floor areas in those verticals favor DAS. So what are the drivers for indoor wireless then? Up until now, it's been voice, but it's becoming voice over LTE or VoLTE, become data-based, and will eventually support higher quality calls and faster call connections. And it will lend itself to new features like location, IPBX, first responder, guest services, and so on. So that's going to be very attractive for in-building wireless owners and operators and users. Another driver is that outside-in RF arrangements are going to start to fail to work at the higher frequencies due to RF attenuation. So since higher frequencies tend to be used by LTE, then that really demands an in-building wireless network. Video is likely to be consumed. Video is driving data, and it's going to be consumed indoors. Bring your own device is another trend that's important for enterprises. And neutral host also continues to hold an advantage over DAS. Finally, one other advantage is that in-building wireless systems increase micro cell capacity, since the micro does not have to serve the hard-to-reach subscriber, and this relieves micro congestion. So what are the in-building blocks? And we've identified 3 or 4 of them here. So we're going to have a look at these in the next couple of slides and try and anticipate what an in-building wireless system in the future would look like. We can see distributed antenna systems, DAS, distributed radio systems, and we can see smart signal boosters here, all playing a part. So the differences between these are distributed antenna systems, or DAS, as the name implies, distributes the antenna and centralizes the baseband and radio. Small cells distribute the baseband, radio, and antenna. Distributed radio systems distribute the radio and antenna and centralize the baseband. And smart signal boosters actually take on some characteristics of small cells for interference mitigation. So thanks to baseband virtualization, small cells will adopt more of the features of DAS and CRAN, or centralized RAN, and make them more economical at higher floor areas than before. So these are our in-building blocks, and one thing we want to say, there's no single solution here, no single architecture for every deployment. It takes a toolbox, and there are no magic bullets for this. So a bit more detail, a bit more of an eye chart. We're trying to outline the advantages of each of these architectures. So for DAS, we're saying that it's excellent for neutral host, network convergence, and large buildings, but it does require dedicated in-building cabling and doesn't scale down to the small buildings so far. Small cells, on the other hand, do scale up to medium-sized buildings, but become less economical in the really large installations. Small cells are not host neutral and increasingly require pretty complex scheduler and macro coordination protocols for interference mitigation. DRS lies between the two and uses virtualization of the baseband to blend small cells and DAS together into a CRAN to fill the gap between DAS and small cells and still remain economical. DRS does, however, require high-capacity fiber fronthaul in the building. Smart signal boosters, SSB, is a new development using self-organizing network features for interference mitigation used in buildings where no usable backhaul exists, or to extend small cell coverage within an enterprise by eliminating coverage dead zones. So finishing up here before I hand over to Jason, the trends we see: 3GPP progression, bringing us increased data rates and reduced latencies, and that's not going to stop as we move to 5G. By 2020, it's complex protocols involving X2 support, EICIC, coordinated multipoint, MIMO, so on, etc. Synchronization, I can go on. Virtualization and centralization is a major trend, and so as we've seen, hope to illustrate that can bring some advantages to small cells and avoid over provisioning and reduce CAPEX. Traffic steering is also a CAPEX and OPEX reduction feature. And finally, network convergence demands a protocol-agnostic in-building wireless system with many bands and access protocols, all converging to LTE and beyond. So we're going to look today at just one of these trends, and that's network convergence. This is our view on network convergence, and I'm sure Jason can talk about this in more depth in the second half of the webinar. Obviously, one system versus several disparate parallel systems is less costly, so that's an advantage. Advanced features can be leveraged on a system like that, like asset tracking, IP video, wireless medical telemetry systems, end-to-end, etc. It's scalable and future ready. You don't need to rip and replace every 7 to 10 years when somebody comes up with a new protocol. It's configurable, therefore you avoid over provisioning and keep TCO and CAPEX down. And fiber everywhere is one of the keys to success here. So finishing off, our takeaways before I hand it over to Jason for the second half is that traffic growth is unrelenting, it's tidal, and it's actually driving innovation in building wireless architectures and systems. Subscribers want always connected everywhere is what they want. Usually indoors, architectures are blending together. No magic bullets, and the four trends we've identified, I'll mention again: 3GPP progression, virtualization and centralization, traffic steering, load balancing, and network convergence can all be leveraged to make future-ready high-performance in-building wireless systems. So thanks for your attention. And before I hand it over to Jason, I wanted to mention that if you want to explore these topics in more depth, we have two reports here shown, which we recently published. So please don't hesitate to get in touch with us to get a copy. And now I'll hand it over to Jason, and thank you for listening.
Okay, so before I get started, I was going to give a little background on myself. So again, my name is Jason Green. I come from originally started on the development side of Corning, and back then, I guess going back 10 years or so, we were looking at various applications where high throughput media or fiber was going to be useful. And fairly quickly, this led us down the path of wireless, because we are on this hockey stick curve of growth, where the device you have today will be different than the device you have a couple of years from now. And as networks grow and technology improves, we tend to take up more and more bandwidth. So it's been an exciting field, and I've been enjoying it. So with that, I'll get into my webinar slides. So my first slide here, we're showing for those of you that have been in IT or may have been into an IT closet, you'll see that it's not atypical to see cable pathways in existing buildings today look like this picture here on the left. What's happened is, as technologies change, we've had many iterations of network cabling. So we've gone to Cat3 cabling, to Cat5, Cat5e. Today, Cat6, Cat6a, even Cat7 in some cases. And with this, it's oftentimes cable's not abandoned, and so you have this kind of hodgepodge of cabling, which makes your life difficult when you go to upgrade, and especially with the needs of wireless today. One of the tricks of wireless is that there are quite a few wires in wireless, and so when we're looking at a building, this is not atypical of something we're looking at. And as I progress the slide, the same is true when we look at our telco closets or IDF closets. As more and more layer 1 devices are introduced into the network, this results in more cabling, and of course more cabling results in more network switches. And so again, we have a lot of congestion in these closets. I can't tell you how many times I've gone to a site where I'm going to be installing a DAS equipment, and just finding space in these closets oftentimes is very difficult. Space is at a big premium. Typically on a building, or it's not uncommon for them not to plan for a DAS system. So when I'm going into a venue and I'm trying to put in some amplifiers into these closets, oftentimes space is a premium. And finally, the last build on this slide. In the wireless world, when we look at the cellular world, we look at spectrum, and spectrum does change fairly frequently. When we look at the different carriers, they're often looking at different methods and technologies to try to handle this rapid growth that they're seeing. And so when that happens, you have new technologies and new spectrums emerge. If we look at AT&T, they're looking at 2.3 gigahertz right now, or WCS. We have 2.5 gigahertz for Sprint that's on the horizon. So many technologies tend to come up, and when this happens, it oftentimes causes rip and replacing of existing systems, or heavy upgrades to try to stay in pace with the technology. And the same is true, I think, if you look at the networking side of the equation as well. As we've moved to needing more powerful layer 1 devices, that's when we've been forced to go from Cat5 to Cat6a and Cat7, et cetera. So what we'd like to do in the last couple of slides here is to try to talk about, what Corning believes is kind of the future of infrastructure in order to avoid these costly rip and replace. scenarios. Okay, my next slide is I'm going to be introducing the WAN solution that Corning has recently released last year. And so Corning was the first to introduce an all fiber distributed antenna system. And what this has allowed us to do is it allows us to push the capacity that fiber provides us down to the edge of the network where it's needed. So it's been a progression. If we look over the last couple of decades, we've had fiber that went across oceans, fibers that were connecting buildings, then fibers were penetrating the vertical or the riser space inside buildings. And we really believe the next frontier is fiber in the horizontal. And one of the big drivers of that is this appetite for more and more bandwidth or more throughput at these edge devices. So what we're able to do is by bringing fiber out to the edge, we provide this unlimited bandwidth via an optical infrastructure. If we look at the building blocks of the system, because this is a fiber-based platform, we aren't limited to distance. So we can have a single head-in that serves a building, or it can serve multiple buildings or a campus environment, which is a common scenario today. So in the MDF or in the head-in location, this is where I'm going to have my carrier base stations as well as the cellular head-in, and oftentimes on these converged solutions where we're converging network elements on the same infrastructure, we'll also have oftentimes fiber aggregation switches if it's a fiber-based LAN, or your traditional core switches. From here, we transport the signals, both the networking signals as well as the cellular signals, to the IDF closet. At the IDF closet for us is really just a fiber aggregation point. And so this is an opportunity for us to aggregate fiber and also inject power into our composite cabling, which provides both connectivity and power for our cellular remote antenna units, as well as network elements like distributed switches or optical network terminals if it's a PON fiber-based infrastructure. Moving on to my next slide. So slide 19, so this is typically what we will see in an MDF location. If we look at a legacy system today, it can require quite a lot of hardware and also quite a lot of fiber as well. So we typically today in a DAS system, you do have fiber going from the MDF to the IDF already today, so that doesn't change with this platform. But when we move on to the WAN system, because we're able to put multiple networks over the same infrastructure, we're able to have a significant space savings. And we're also able to eliminate the WAN system is smart in that it eliminates a lot of the traditional RF cabling that you have going into a system, where on a legacy platform you are combining multiple frequencies before it goes into the DAS. The WAN system has a switching matrix or a backplane where we're actually able to combine those signals as appropriate, and we're also able to actually steer that capacity or provide the capacity from that base station. We can move it to various remotes because we do have that connectivity all the way to the edge with an optical remote. The same is true when we look at a fiber-based network or a PON solution. With a PON solution, a single PON port, because it's fiber and we have this high bandwidth, can support up to 128 layer 1 devices or edge devices. And that's just a single port. So if we expand that out to a chassis, they're not a typical 9U chassis for a fiber aggregation switch or an OLT would support over 7,000 devices. So again, this allows us to save significant space in the head-in as well as the IDF closet. So as we look at an IDF closet, this is an actual a design scenario that we've done recently at a hotel. We originally had designed this with one of our legacy platforms, the HX platform, and it required a total of 5 racks of equipment if I look at all the different IDF closets that were throughout the hotel. When we actually started to look at the one platform for this product, because oftentimes in these kind of venues spaces at a big premium. And so we were able to go from 5 racks of equipment or 17 HX units to just a single rack of equipment, which houses the essentially those fiber aggregation points, which is just again a point to a patch panel for the fiber and also a point for power injection when we're going into that composite cabling. The other nice thing about the one solution in terms of space savings is these ICUs, again, because it is fiber and we're not distance limited, these ICUs can be located anywhere throughout a building. So another recent deployment that we've done at a hospital on the West Coast, we actually had a situation where the hospital didn't allow us access to any IDF closets for whatever reason. So in that case, we were actually able to eliminate all IDF closets in the deployment and feed everything directly from the head end. So we just located those ICUs, the power injection points, in the head end, and we were able to serve a hospital which was well over 1 million square feet from a single building. So again, the fiber itself gives you a lot of flexibility when you're looking at these venues. Moving to the horizontal, or the fiber that's leaving the IDF closet, or the cabling that's leaving the IDF closet. In a typical hybrid fiber coax DAS or a legacy DAS platform, you're going to have half-inch coax leaving that closet, and the half-inch coax will be serving various antennas in a distributed environment. So these cables can be a little bit more difficult to install and often requires specialty labor to get that done. Conversely, because the one platform is a fiber-based system, we're able to replace many of those coax cables with just a single fiber cable. And the nice thing about fiber itself, in that since fiber is a universal media, we're able to take that fiber and serve not only our DAS or our cellular needs, but we can also use that fiber to serve other networking or layer 1 type devices like Wi-Fi, like location, point of sale, etc. So we are utilizing this fiber in today's environments. That's when Nick was talking about convergence. That's what we're talking about. We are using this single cabling to support multiple networks. And again, we're able to do that because of the bandwidth of fiber. So we're able to leverage this fiber now that it's further out into the network, and we're able to do much more with it. So slide 22, this is going to be discussing kind of the differences in a traditional approach versus the new One Wireless platform. So in a traditional approach, we have amplifiers that would be these what we call remotes commonly will be located in IDF closets, and these would essentially push coax or power out here, and we would use splitters and feed multiple antennas from a remote antenna unit. With the One Wireless platform, the configurations is closer to Wi-Fi, and that I have an active element at the edge of the network. This element out of the gate provides me 5 bands, and I also have an expansion slot there. Number 2 is the expansion slot, where I can add 2 additional bands, or I also can use that expansion slot to add MIMO services. Comparatively to a legacy system there on the left, if I want to add MIMO, that requires that I add a new amplifier or double my equipment in the closet, but it also forces me to add a second run of coax to get that multi-in, multi-out service, which is often used by the carriers to increase capacity. And then we also have the Ethernet element here. So we have a couple of different ways where we can handle Ethernet at the edge with the one platform. We have that label number 3, a gigabit Ethernet module that is used for a traditional switching network, essentially a 2-port switch that can feed back to your access switch in the closet, which allows you to provide services like Wi-Fi, like location. We can use that and feed another small switch if you want to have multiple ports out. So that's one of the methods that we use. Another method that we use, and especially a lot of our large deployments, is passive optical LAN. So passive optical LAN is that technology that I referred to in the previous slide. Here I would use those spare fibers that I have in my cabling. So I have a single fiber cable, multiple fiber strands under that sheath, and I can utilize that spare fiber to feed optical network terminals, and from that point I can feed many devices I can feed a lot of the deployments that we do. It's the entire technology package, or the entire IT infrastructure is being fed by this one platform. So to put this in a picture form, so today this would be a picture of a excuse me, a legacy hybrid fiber coax system. So if I have a SISO deployment, so if I have a deployment today and I decide I want to use SISO to meet my coverage needs and also my capacity needs, I would have a coax cable that would leave the closet, and that would feed an antenna or multiple antennas if I'm using splitters. As I progress the slide, as I move to MIMO, or as I have needs for more capacity, I'm forced to double my equipment in the IDF closet, also in the MDF closet, but I'm also having to add more infrastructure. And this is the half-inch coax that tends to be a little bit more difficult to install as well. This is the cartoon for the one platform. So in a SISO environment, again, I have this single cable. This dotted line is representing a composite cable where I'm providing both fiber connectivity as well as power. In a SISO deployment, this is what it would look like. And when I want to add MIMO, because I have this high bandwidth media, this fiber, I'm able to do that without adding any new infrastructure. I simply add that expansion unit module to the remote antenna unit, and I'm able to provide MIMO services or add additional bands. So this is that same hotel scenario that we looked at the previous slide when we want to go to MIMO. So originally I had, I think, 5 racks of equipment and 17 remotes. When that hotel wants to go to MIMO, or when the carriers decide they want more capacity at that site, that would require us to double those amplifiers. But again, on the one platform, because we have that high bandwidth media at the edge there, we're able to provide the MIMO service without adding any new equipment in the IDF closet. As you can imagine, this saves considerable cost. So again, to summarize, the addition of new technologies and/or MIMO services on the one platform, you would essentially just add an additional card to our head-end. So this is just the card that can interface to the carrier's RF source to provide either that new technology, new band, or MIMO services. At the remote end, I would add our remote expansion unit, which would provide me additional bands or that MIMO capacity. And then third, I would just simply go into the GUI. In the GUI software, I can essentially configure that RF path to show where I want MIMO. This is also the location or the method I would use if I want to do some steering of capacity. If I decide I want to have more capacity at a certain area of a building or at a certain part of a campus, I can also do that via the software because I have this switching matrix at the head end. And this slide does a good job of kind of illustrating this capacity steering or flexible sectorization. So essentially what you're seeing here on the left is a typical DAS network or hybrid fiber coax DAS network. And typically when we deploy a DAS, what we do is we have all the services at the head end or at the basement of the building, and all those services are feeding all antennas throughout a venue. What we can do with the one platform, because we have this switching matrix, is we can actually put different services in different parts of the building. So we can do that if we have, if it's a multi-tenant space, if some floors want to have all 4 carriers as an example, and other floors, are only interested in 1 or 2 carriers, we could do that through that switching matrix and the GUI interface. But the other maybe more interesting thing we can do is in venues, and on the right-hand side here, is we can actually change the sectorization or change where that capacity is directed based on the needs of the building. So there's 2 examples that I like to use. The first example is like a hotel with a conference center. So oftentimes with a hotel and a conference center, you want to have, during the evenings, a lot of capacity on the tower and the hotel rooms, because this is where the road warriors are coming back at night. They're streaming the Netflix, all those different applications that Nick talked about. They're running those from their room, which tends to be very data hungry and requires a lot of capacity. But after 9 o'clock in the morning or 10 o'clock in the morning at a typical hotel, there's nobody in their hotel room. So you'd like to be able to use that capacity and push it out to the conference center if there's a conference center on site. And so you wouldn't leave no capacity on those upper level floors, but you might go from 2 or 3 sectors at the hotel rooms to a single sector and push those extra sectors down to the conference center or the casino or whatever you happen to have. The other common scenario for this application is in a campus environment. So if you have if you look at a typical college campus, let's say, all the carriers are very interested in going into the sports venues. So the football stadium is an example. You might have, 20 sectors, 30 sectors, or even 50 sectors of dedicated capacity for these huge football stadiums, which are used, 6-7 games a year on a Saturday. But what they'd like to be able to do, and what we're doing today, is taking that capacity from that stadium, and when it's not game day Saturday, push it to the dorms or push it to the library or other buildings on campus. And again, because we are using fiber and we're not distance limited, we're able to push that capacity actually to multiple buildings to best use that investment. Slide 28 shows a typical installation of a converged system. So this first layer that you see here is we're using a passive optical LAN or passive optical network. So this POL device is what we call a fiber aggregation switch. So here we are taking all of our various network services, and via a fiber infrastructure, we're able to feed multiple devices. At the edge here, we would have an optical network terminal and just a short category cable jumper that would be going to my computer and my phone, Wi-Fi access points, building automations, etc. But again, because it's a fiber infrastructure and it's a universal media, when we want to add DAS, the infrastructure doesn't change. So I just take the spare fiber from the network system itself, and now I can add DAS over the same infrastructure. So this provides a lot of benefits to everybody involved. The total cost goes down. I'm installing just a single infrastructure versus multiple infrastructures. I've got this future-based system that I can support the needs of today, but also the needs for tomorrow. So we believe it provides a lot of advantages for the entire ecosystem. And what that would look like here on slide 29 is here is our cellular system with the one platform, so the fiber-based platform. I'm sorry, this is a traditional, so this is my legacy system where I've got fiber from the MDF to the IDF, coax feeding antennas. But when I add my network elements, that of course is a parallel system, and now I have to add my switching gear, and I also have to add category cable to feed WAPs and feed my various layer 1 devices. If we look at the same kind of solution on the one system, again, because we have this fiber-based system out in the horizontal, we're able to leverage that fiber, and with that fiber, we're able to kind of create a zone infrastructure, if you would. And so from this active remote antenna unit, we can also feed many network devices with just short category jumpers. And then the same thing is true when we look at upgrades or adding additional devices on a traditional network. When we're adding additional devices, that requires additional category cable as well as additional electronics. But on the one system, again, because we have this high bandwidth media and fiber, when we want to add devices, we can simply just patch into that fiber at the zone and feed additional layer 1 devices. Those are the slides I have today. So with that, I'm going to hand it back over to Kyle for questions.
All right, thanks, Jason. We've had a number of great questions come in during the presentation, and I encourage everyone to submit any they may have. But anyways, we'll jump right in. The first question we got is for you, Jason. It's, with the recent focus on in-building location, what can be done within a DAS system to augment or provide 3D location?
Good question. So we actually work with a couple of different technologies for location. So one common way we handle location is so one method would be, of course, like Bluetooth location. So we do have deployments today where we're leveraging this fiber infrastructure and the bandwidth at that fiber infrastructure to feed essentially Bluetooth locators, and so that gives us sub-meter accuracy. There's other methods, of course. You can do Wi-Fi location as well, which is also supported through this system. And we're also looking at some advanced options with LTE to also get location into anywhere from that below 1 meter to 5 meter and less. So there's several technologies that we are working with, and that's I think the nice thing about this platform in general is that it is very flexible, so that we can work with various vendors to handle location.
Great. We had another question come in for you, Jason. Are the active antennas fed by fiber for GE Ethernet?
So the remotes themselves are fed with what we call composite cabling. So under one sheath we have fiber, but we also have copper, which is providing the power. So we offer this cable in various configurations, anywhere from a single pair of fiber to a single pair of copper, all the way up to 24 fibers and 12 conductors. But essentially what we're doing is we're providing the fiber connectivity. We're also providing the power, and with that we're able to connect various devices. So of course our remote antenna units for cellular, but we're also able to use that fiber and that power to power other devices like ONTs, like network switches, etc.
Great. And Nick, we do have a question for you. Does ABI have any forecast around penetration in smaller buildings? And if so, do you have any roadmap for when this will start?
Yes, we do. Thanks, Kyle. A good question. We talked about small cells. We talked about in-building wireless. And we forecast in-building wireless in two ways. One with DAS. And so far we are forecasting that meaningful deployments have been occurring and are occurring in buildings over 100,000 square feet in size, with relatively few systems at the smaller building sizes. Then we also forecast small cells in buildings, and they, as I mentioned in the webinar, they're more economical for smaller building sizes like SMBs, and we anticipate that small cells will move up to tackle larger building areas and come head to head with DAS in some situations. So yeah, we have forecasts for each of those, and the in-building small cells haven't really taken off in any meaningful way yet, but we do anticipate that starting to happen in 2015 and on.
All right, great. And we actually got a follow-up question to that one. So, Nick, what will drive enterprises to fund these type of systems, and what in these verticals as well as others?
Yeah, very important question. You can see that from Jason's presentation that it's the features that are enabled by these advanced systems. Enterprises want to make sure, for example, that employees and guests have 5-bar access everywhere. BYOD is a very important trend that enterprises want. Location we talked about, first responder we talked about, but that's important. Wi-Fi, obviously, IPBX. And so network convergence really becomes pretty important to leverage all those functions and access protocols into the one system wherever possible.
Great, thanks. Jason, we have another question for you. Are there integrators out there capable of installing converged solutions?
Absolutely, yeah. So we've, this right now is kind of our focus for Corning. So we do have quite a few installations under our belts, and it is something I think our integrator network is actually quite excited about, because it allows them to, add more value, right? So, Yeah, so the answer to that question is yes, and if you're looking for an integrator partner that can handle this kind of network that we talked about today, happy to talk with you offline.
Great, and we received another question slash comment, really aimed at Nick, but I think this could work for both of you guys. So is there a mismatch between Nick's statement saying that 85% of US will be LTE in 2019, while DAS radio heads can only support MIMO for LTE in 2 bands out of 5? Do you guys see this as a limit to spectrum refarming?
Yeah, so I can, I think, address it. So the expansion slot on the one remote, it's correct. It is 2 bands, and so that would provide 2 bands of 2x2 MIMO. But we are already deploying systems today where they're wanting to do more than 2 bands, of course, 4 bands. So a lot of the large public venues that we're deploying today, we are deploying 4 bands of MIMO. We're simply doing that by simply just adding another remote at the edge. Typically on these fiber cablings, we are over provisioning the fiber to allow for additional bands. And today, most of these venues we're talking about 2x2 MIMO, but we can even go beyond a 4x4 MIMO, and some carriers are already looking at this. So again, the nice thing about this infrastructure, because I have the fiber and I have the high bandwidth there, I can go from 2 bands of MIMO to 4 bands of MIMO to 4x4 MIMO, very easily without having to upgrade my infrastructure.
Great. And also, we had another question just asking, what exactly does DRS stand for, and what does that mean?
This is Nick. I'll take that one since I introduced the term distributed radio system compared to distributed antenna system. Distributed radio system distributes the radio and the antenna and centralizes the baseband in the telecom closet. And that's the hybrid between DAS and small cells that are covered in the slides.
Thanks for that answer, Nick. The next one we had was for you, Jason. What would motivate an integrator to expand into offering converged solutions?
Well, I can give you even maybe some examples. So the nice thing about convergence for the integrator market, and our integrators are particularly excited because it adds, it provides, more to their plate essentially, right? So if I have a traditional DAS infrastructure, let's say I have a venue that's got 200 antennas, right? And so if I'm a DAS integrator today, my scope of work is, to install and commission those 200 antennas. But if that becomes a converged network, now I'm also responsible for many of those additional network elements. So if I have 200 antennas, that might mean I have 500 or 600 network devices, whether that be Wi-Fi or point of sale or building automation, et cetera. But typically what that happens for our integrators that are doing that installation, their share of the pie actually goes up because they're able to do more and provide more value to the end client.
All right, great. And then we had another question for you, Jason. Are converged solutions already installed anywhere?
Yes, we do have quite a few installations, and I think there's going to be a follow-up webinar that is going to go over some specific use cases of actual deployments that have taken place this year. So I won't name names on this webinar, but I will say that we have upcoming webinars that'll go over some specific use cases venue by venue.
Okay, great. Looks like we're just about out of time. We have time for, I'd say, 1 or 2 questions, but Jason, we had one question. What major obstacles would you expect in implementation of DAS and fiber as we move forward?
I mean, the challenges are kind of the similar challenges. I mean, to be honest, the biggest challenge that we have typically is funding, especially for these enterprise projects. That tends to be the biggest focus is funding, because these aren't inexpensive systems. But I will say that now that we're looking at convergence, we do have the ability to pull from multiple budgets. So it's always helpful when I can pull from the telecommunications budget and also the IT budget, and maybe my security budget, to provide a one converged system. What happens is my total cost goes down. I'm able to pull from multiple buckets, which makes the likelihood of a project kicking off improve significantly.
Great. Here's a question we just got in that I think would be best for you, Jason. How do you see TDD technology supported by current DAS?
Sure. So yeah, I mean, so to TDD technology, I mean that it was simply is going to require that we have we would handle that today in either an expansion module or a dedicated remote, and we would have just simply a different interface at the head end to go to that RF source. But TDD is something that's out there. Don't see it as much in the U.S., but in other markets, it is certainly something that we're looking at very seriously.
Okay, great. That's about all the time we have. I want to thank everyone for attending 2015 Outlook for Indoor Wireless Technologies, presented by Corning and ABI Research. Again, our presenters today were Jason Green, Solution Architect for Corning Optical Communication, and Nick Marshall, Research Director at ABI Research. Thank you guys for your time.
Thank you for your attentiveness.